If you look closely at a single dot of ink on a piece of paper, the dark pigment appears dense and completely solid. Yet hidden inside that tiny mark are roughly 90 trillion individual carbon atoms. This presents a physical paradox. We interact with ink, paper, and tables as firm objects, but the atoms making them up are 99.9999% empty space. If matter is mostly a void, what forces actually give the universe its physical structure? This visual model shows the answer. Reality structure relies entirely on how three fundamental subatomic particles perfectly balance two critical properties: relative mass and relative charge. To see how this balance works, we have to travel into the absolute center of the atom, to an unimaginably dense core known as the nucleus. This diagram isolates the first particle, the proton. It carries a positive electrostatic charge of +1 and a relative mass of 1. The exact count of these protons is known as the atomic number. The atomic number is the defining characteristic that determines whether an atom is carbon, oxygen, or any other chemical element. Sharing the nucleus is the neutron. Neutrons have an equal relative mass of 1, but they lack any electrostatic charge, sitting perfectly at 0. The nucleus creates an extreme paradox of volume versus weight. It is 10,000 times smaller than the total width of the atom, yet those tightly packed protons and neutrons contain over 99% of the atom's entire mass. Look at this notation block showing how the nucleus acts as the atom's heavy positive anchor. The mass number at the top adds up the protons and neutrons, while the atomic number below defines the element using just the protons. Moving away from the dense center, we pull out into the vast empty space that makes up the rest of the atom's radius. This topological map shows where the third particle lives. Found in specific orbital shells, the electron carries a negative charge of -1 and a mass of roughly 1/1840th of a proton. Because the electron's mass is so remarkably small, it is typically approximated to 0 in standard calculations. It contributes almost nothing to the overall atomic weight. So what holds this massive empty space together? The heavy positive nucleus projects a constant attractive force, pulling on the weightless negative electrons and keeping them locked in their orbits. In its default state, any neutral atom maintains perfect electrical parity. The number of positive protons in the center exactly equals the number of negative electrons on the outside. This precise cancellation of +1 and -1 charges results in an uncharged atom, establishing the stable baseline for all physical matter in the universe. This summary table reveals the complete structural blueprint. Heavy protons and neutrons are safely grouped in the nucleus, while the weightless, negatively charged electrons occupy the distant shells. Because electrons reside on the outermost perimeter and weigh almost nothing, they are uniquely positioned to interact directly with the outside world. This model illustrates what happens when external forces hit the atom. If an electron absorbs electromagnetic radiation, which is simply a wave of energy traveling through space, it becomes excited and jumps to higher energy levels. Study, through all of this volatile movement in the outer shell, the heavy core remains untouched. The atom's mass and its elemental identity stay safely locked away. Chemistry happens when that perfect electrostatic balance is broken. Every chemical reaction is driven entirely by the swapping and sharing of these weightless outer electrons.